Welcome to this rigorous scientific lecture on using artificial intelligence as your personal cognitive coach to accelerate learning speed. Today we'll explore evidence-based protocols, quantitative frameworks, and practical implementation strategies. Before we dive into the practical framework, we need to understand the cognitive science principles that make this approach effective. Research from Ebbinghaus and modern cognitive psychology shows that spaced repetition can increase long-term retention by 200 to 400% compared to massed practice. Retrieval practice, where you actively recall information, strengthens neural pathways far more effectively than passive review. This is known as the testing effect. Immediate feedback is critical. When you practice incorrectly, without feedback, you consolidate the wrong patterns. AI provides instant correction, preventing this issue. So why use AI specifically? What advantage does it provide over traditional study methods? Let me ask you, what makes AI superior to traditional tutoring or self-study? The answer is threefold. First, infinite patience. AI never gets tired or frustrated. Second, instant availability at any time. Third, adaptive difficulty that adjusts in real time based on your performance. Compare the economics. A traditional tutor costs approximately $50 per hour with limited availability. AI coaching costs around $20 per month with unlimited access. That's a 50x cost reduction with greater flexibility. Now let's establish the weekly protocol. This is a rigorous, systematic approach based on deliberate practice principles. The framework consists of three core components: pretest, daily microdrills, and scorecard tracking. Let's start with the pretest. This is your diagnostic baseline. Every Monday morning, you take a diagnostic assessment in your target learning domain. This could be mathematics, programming, language learning, or any skill. Keep it concise, 20 to 30 minutes maximum. You want a snapshot of current performance, not exhaustion. Measure two critical metrics: accuracy percentage and completion time. These are your key performance indicators. Here's a concrete example. You're learning calculus derivatives. You take a 20-problem diagnostic. Your baseline is 65% accuracy in 28 minutes. The AI identifies weak areas: chain rule and product rule. Your baseline score is 65%. This is week 0. The AI analyzes your specific error patterns. It doesn't just mark answers wrong. It identifies misconceptions, computational errors, and conceptual gaps. Then it generates personalized drill sets targeting exactly those weaknesses. Now we move to the daily microdrills. This is where the real learning acceleration happens. 15 minutes per day, no exceptions. Consistency beats intensity. The brain learns better with distributed practice than marathon sessions. You might ask, why only 15 minutes? Isn't more practice better? The answer comes from cognitive load research and habit formation studies. 15 minutes is below the threshold where motivation breaks down. It's sustainable indefinitely. More importantly, frequent short sessions with sleep intervals between them enhance memory consolidation. The microdrill structure is highly specific. Let me break it down. Minutes 0 to 5. Targeted problems on your weakest areas identified from the pretest. Minutes 5 to 10. Mixed review of previously mastered concepts to prevent decay. Minutes 10 to 15. Challenge problems slightly above your current level. This is the growth zone. Visualize it as 3 zones: red zone for weaknesses, yellow for review, green for growth. Each session follows this exact pattern. The AI adjusts difficulty in real time. If you nail 3 problems in a row, difficulty increases. If you miss 2 consecutively, it steps back. This is adaptive learning at work. Now let's discuss the scorecard system. This is your quantitative feedback loop. You track 4 metrics with scientific precision. This is non-negotiable for measuring progress. Metric 1, daily accuracy percentage. What fraction of problems did you solve correctly? Metric 2, average time per problem. Speed matters. Fluency requires both accuracy and velocity. Metric 3, weekly improvement rate. How much better are you compared to last week? Metric 4, confidence calibration. How well does your perceived difficulty match actual performance? This reveals metacognitive accuracy. Here's what 4 weeks of data looks like. Week 0, 65% accuracy at 84 seconds per problem. By week 4, 89% accuracy at 58 seconds. That's a 24 percentage point improvement and 31% faster completion. We can calculate learning velocity as the change in accuracy divided by the change in time. This gives you a single metric for overall improvement rate. For this example, the learning velocity is 89 minus 65, divided by 4 weeks, which equals 6% improvement per week. Let's do some back-of-the-envelope calculations to quantify the value of this approach. Here's the question. How much time does this AI-coached system save versus traditional study methods? Traditional approach. Most people need about 2 hours of daily study for 12 weeks to reach proficiency in a typical domain. That's 168 hours total. 2 hours per day times 7 days times 12 weeks equals 168 hours. AI-coached approach. 15 minutes daily, that's 1.75 hours per week, plus 30 minutes for weekly assessment. Total 2.25 hours per week. With accelerated learning, you reach the same proficiency in 8 weeks. That's 2.25 hours per week times 8 weeks, which equals 18 hours total. Time savings. 168 minus 18 equals 150 hours saved. That's an 89% reduction in time investment. That's 150 hours you get back. Add a conservative value of just $20 per hour of your time. That's $3,000 in value created from a $20 per month investment. Now let's explore the neuroscience behind why microdrills are so effective. Sleep-dependent memory consolidation is the key mechanism. When you practice something, then sleep, your brain consolidates that learning during slow-wave sleep. Daily practice means daily consolidation. Each practice session triggers protein synthesis in the specific synapses you're using. This strengthens those neural pathways. But protein synthesis takes time, approximately 6 to 8 hours. You might wonder, why not just do 105 minutes once per week instead of 15 minutes daily? The answer is that mass practice doesn't allow time for consolidation. You're trying to force-feed information faster than your brain can biochemically process it. It's like trying to water a plant with a fire hose. The soil can't absorb it fast enough. Research shows massed practice yields approximately 40% retention after 1 month. Distributed practice yields 85% retention. Same total time, double the retention. Let's get practical. How do you actually implement this system? Option 1. Use GPT-4 or Claude with carefully crafted prompts to generate your drill problems. You maintain a conversation thread where it tracks your performance. Option 2. Use specialized platforms like Khan Academy or Brilliant that have built-in adaptive learning algorithms and progress tracking. Option 3. For memorization-heavy domains like medical terminology or vocabulary, use Anki with AI-generated flashcards. The AI creates cards. Anki handles the spaced repetition scheduling. The critical factor isn't which tool you choose. It's whether you use it consistently and whether you measure your metrics rigorously. Let me give you a concrete weekly schedule that you can implement starting tomorrow. Monday, 7 a.m. Take your 30-minute pre-test. Analyze weaknesses. Tuesday through Saturday, same time every day. 15-minute micro-drill. Log metrics immediately. Daily evening. Review your scorecard, adjust focus. Sunday is rest. Passive review only. Total investment, 2.25 hours per week. Expected results, 5 to 7% weekly improvement. Now let me share an advanced technique, interleaving. This enhances transfer of learning. Instead of practicing the same problem type repeatedly, you mix different types within a single session. Interleaving forces your brain to actively discriminate between problem types. This builds pattern recognition and improves your ability to identify which technique applies to novel problems. Example, in a calculus drill, mix derivatives, integrals, and limits randomly rather than doing 10 derivative problems, then 10 integral problems. Research shows interleaving improves transfer learning by 30 to 40% compared to blocked practice, even though it feels harder during practice. Let's discuss the confidence calibration score. This is an underutilized but powerful metric. After attempting each problem, before seeing the answer, rate your confidence as low, medium, or high. Then compare your confidence ratings to actual correctness. This reveals metacognitive accuracy. Here's what good calibration looks like. High confidence correlates with 90% accuracy, medium with 65%, low with 30%. If high confidence only yields 40% accuracy, you're overconfident. If low confidence yields 85%, you're underconfident. Overconfidence is dangerous because it leads you to underpractice weak areas. You think you know it, but you don't. Underconfidence wastes time drilling material you've already mastered. Both reduce learning efficiency. The AI helps by tracking your calibration scores over time and alerting you to systematic biases in your self-assessment. Let's calculate return on investment using what I call the learning efficiency ratio. Learning efficiency ratio equals skill gained divided by time invested. Skill gained is measured as percentage point improvement in accuracy on standardized assessments. Let's use concrete numbers from our earlier example. Skill gained, 89% minus 65% equals 24 percentage points. Time invested, 18 hours over 8 weeks with the AI-coached method. Learning efficiency ratio is 24 divided by 18, which equals 1.33 percentage points per hour. Compare this to traditional methods. With 168 hours to gain 24 percentage points, that's 0.14 percentage points per hour. The AI-coached approach is 9.5 times more efficient than traditional methods, nearly a 10x improvement in learning efficiency. Now let's address common pitfalls people encounter with this system and how to avoid them. Pitfall 1. Skipping the pretest because you're afraid of scoring poorly. This is self-sabotage. You need baseline data to measure improvement. Solution. Reframe the pretest as pure data collection, not evaluation of your worth. Bad scores are good data. They tell you where to focus. Pitfall 2. Doing drills at different times each day. This disrupts habit formation and reduces compliance. Solution. Same time every day, non-negotiable. Treat it like taking essential medication. Morning is optimal for most people due to willpower depletion later in the day. Pitfall 3. Failing to log metrics immediately after each session. Memory is unreliable. You'll misremember your performance. Solution. Create a simple spreadsheet. Before you close the AI interface, log your 3 numbers: accuracy, time, confidence calibration. Takes 30 seconds. Pitfall 4. Giving up after 2 weeks because progress feels slow initially. Learning curves are nonlinear. Early weeks build foundation. Solution. Commit to a minimum of 4 weeks before evaluating effectiveness. Week 3 and 4 typically show acceleration as foundational patterns solidify. Let's examine the neurobiology to understand why this protocol is so effective at the mechanistic level. Skill acquisition has 3 stages. Stage 1 is the cognitive phase. High mental effort, slow performance, lots of errors. This is weeks 1 and 2. Stage 2 is associative. Mental effort decreases, performance speeds up, error rate drops. This is weeks 3 through 6. Stage 3 is autonomous. The skill becomes automatic, requiring minimal conscious effort. This is week 7 onward. The AI system accelerates transition between these stages by providing perfectly calibrated difficulty and immediate error correction, which prevents formation of incorrect motor programs. Visualize the progression. Red cognitive phase is weeks 1 and 2. Yellow associative phase is weeks 3 through 6. Green autonomous phase is week 7 onward. The AI accelerates movement through these stages. At the cellular level, focused repetitive practice increases myelination of the neural pathways you're using. More myelin means faster signal transmission, which manifests as increased speed and reduced errors. Let me walk you through a concrete case study. Learning Python programming from 0 to functional proficiency. Week 0 pretest, 20 basic programming problems. The learner scores 25% accuracy, taking an average of 12 minutes per problem. The AI identifies weak areas: basic syntax, loop structures, and conditional logic. These become the focus of Week 1 drills. Week 1, daily 15-minute sessions. First 5 minutes on syntax errors, next 5 on loop practice, final 5 on conditional logic problems. Week 1 results. Accuracy jumps to 42%. Time drops to 9 minutes per problem. That's 17 percentage points improvement in 1 week. By week 4, 78% accuracy, 4.5 minutes per problem. The learner has gone from barely functional to solid intermediate level. Total time investment, just 18 hours over 4 weeks. Traditional boot camps require 200+ hours to reach similar proficiency. One critical success factor deserves special emphasis: the immediate feedback loop. Human working memory holds information for only 20 to 30 seconds without rehearsal. If feedback is delayed, the context is lost. AI provides correction instantly, while the problem is still actively held in working memory. This creates a tight association between the error and the correction. Compare this to traditional homework, where feedback comes hours or even days later. By then, you've moved on mentally. The error has potentially been reinforced through repeated incorrect practice. You might ask, what is the optimal delay for feedback to maximize learning? Research shows 0 to 10 seconds is optimal for procedural and computational skills. AI easily achieves this. Human tutors cannot, due to think time and communication lag. Let's explore advanced metrics beyond simple accuracy and speed. We want to track learning velocity over time. Learning velocity as a function of time equals the derivative of accuracy with respect to time. This tells you your instantaneous rate of improvement. Plot your learning velocity weekly. This reveals plateaus, where progress stalls, and breakthroughs, where it accelerates. Plateaus indicate you need a strategy change or difficulty increase. If velocity drops below 2% per week for 2 consecutive weeks, the drill difficulty is too easy, or you need to target different subskills. The power law of practice states that performance improvements follow a power function: large initial gains, then diminishing returns. This is normal and expected. Time to complete task N equals time for first trial times N to the negative alpha power. Alpha is typically between 0.2 and 0.6. Practically, this means expect about 50% of your total gains in the first 25% of practice time. Don't be discouraged when later gains come slower. That's mathematically inevitable. Let me synthesize everything into the complete system workflow. Step 1. Monday diagnostic establishes baseline, identifies weaknesses, generates personalized drill content. Step 2. Tuesday through Saturday. Daily 15-minute micro drills target identified weaknesses with adaptive difficulty. Step 3. Immediate logging of accuracy, time, and confidence after every session. Step 4. Evening review of scorecard, identifies trends, triggers adjustments for next day. Step 5. Sunday rest day allows neurological consolidation and prevents cognitive burnout. Step 6. Repeat cycle, watching metrics trend upward week over week. This becomes a positive feedback loop, driving sustained motivation. Now let's address why most people fail at systematic learning approaches, and how you can succeed where others don't. Failure mode 1. No concrete metrics. They rely on subjective feelings of improvement rather than quantitative data. Feelings are unreliable. Failure mode 2. Irregular practice schedule. 3 days on, 4 days off. This breaks the habit loop and prevents consolidation. Failure mode 3. Marathon sessions rather than micro drills. 2-hour sessions once per week are far less effective than 15 minutes daily. Success strategy. Treat this as a scientific experiment on yours. You're the subject. The AI is your lab equipment, and the metrics are your data. Share your weekly scorecard with an accountability partner. Social commitment increases compliance by approximately 65%, according to behavioral research. Finally, let's talk about the long-term vision. This isn't just about learning one skill. It's about building the compound learning capability. You master one domain in 8 weeks using this protocol. Then you apply the same system to a second domain. Each successive domain is learned faster due to meta-learning. You've learned how to learn. The protocol itself becomes automatic. After mastering 5 domains, your learning efficiency doubles again. You've built the cognitive infrastructure for rapid skill acquisition. At 8 weeks per skill, you can master 6.5 new skills per year while investing only 2.25 hours per week. Over 10 years, that's 65 distinct skills at expert level. This is how you build genuine polymath capability. The compounding effect is exponential, not linear. Skills interact and reinforce each other. Programming plus statistics plus domain knowledge creates data science expertise. Let me conclude with the bigger picture. We're at the beginning of a scientific learning revolution. AI has democratized access to personalized adaptive instruction, that was previously available only to elite athletes with dedicated coaches. The protocol I've outlined isn't speculation. It's based on decades of cognitive science research on optimal learning conditions. You now have the complete framework. Pre-test for diagnosis, micro-drills for practice, scorecard for feedback. Success requires only 2.25 hours per week of investment, but it demands genuine commitment to the protocol. The question isn't whether this works. The research is clear. The question is whether you'll actually implement it with scientific rigor. Start tomorrow. Take your first pre-test. Begin your first micro-drill. Log your first metrics. The compound returns begin immediately. 1 year from now, having mastered 6 new skills using this system, your future self will thank you for starting today.